Alright, today we're going to talk about 3.1, which works on oblique triangles. Now you can ask yourself, what is an oblique triangle and why are we messing with it? We've gotten very, very good at solving for missing sides if there's a 90-degree angle. We can use SOHCAHTOA and we can use Pythagoras. But an oblique triangle is a triangle that does not have a 90-degree angle. If there is not a 90-degree angle, I have two things I can use. I can use law of sines. I just spelled law wrong. Let's try this again. Of sines or law of cosines. So, in 3.1, we are going to deal with the law of sines. We will not use SOHCAHTOA. And it'll be really apparent when you get into your homework and stuff that SOHCAHTOA and Pythagoras will not work because the triangles we deal with are going to be oblique. So, let's jump in. It's pretty exciting. I think you guys are going to enjoy this. So here we go. The law of sines, simply stated, is little a divided by the sine of a equals b over the sine of b. So at this stage in our learning, you guys are going to accept this relationship. When you come to class, we'll make sure I show you where this comes from. But basically, the idea is, given any triangle, and we're going to label our triangles A, B, C. Capital A is going to stand for an angle. Little a is going to stand for a side length. So, anytime I have partners are an angle and the opposite side length. So big A and little a are partners. Capital B and little b are partners. Capital C and little c are partners. And if you notice, my partners go together. Alright? Actually, when we write this, we can also say C divided by the sine of C. And we will choose whichever set of partners we need. So we'll jump in right now and make sure we're ready to rock and roll. So we're going to start with this. I believe I called this problem number 1 on your notes. So problem number 1, we're going to be given two angles, angle C, angle B, and then a side length of B. So the first thing to start all these problems is we are going to draw a picture. Doesn't matter how you draw your picture, just make sure you get A, B, and C, and then my side lengths. So if I know that angle C is 102, I can write that inside my picture. I also know that angle B is 28.7. And I know that little b is 27.4. So, the first thing I recognize is I can use the law of sines, or I have to use the law of sines because I do not have a 90-degree angle. So I have an oblique triangle here, and I have to find all of the missing pieces. I think the easiest one to find first is my side A, or excuse me, my angle A. All the angles in a triangle have to sum to 180. So if I'm looking for angle A, I can solve that by taking 180 minus my other two sides, 28.7, and then I can also subtract 102.3. And when I subtract all of that, I will get 49 degrees. So I know that that missing side is, or excuse me, that missing angle is 49 degrees. Now that I have all my angles, I can go ahead and find my side length. If you look, we got to have partners. So the easiest way is to have partners. I definitely have a partner between B and side B. So I'm going to use those two first. I am going to say B over the sine of B equals, and let's see, which one do I want to solve for, A or C? It doesn't really matter which way we start, so let's start with C. I need a side length C over sine of C. So we can substitute in, and let's see what we can do. I know side length B is 27.4, and I know angle B is the sine of 28.7. I almost can't see it with my highlighting. Equals little c divided by the sine of c, 102.3. Alright, so once I have that set up, now the question is, can I actually do the algebra? So if I'm solving for c, I have to do the opposite, which means I have to multiply by the sine of 102.3. So then those will cancel out. On the other side, I also have to multiply by the sine of 102.3. And once you put that in your calculator, I think we're going to get an answer. I think we will end up with C equal to, and you type this into your calculator, do not just copy my work, but I think I get 55.74. Okay, so now we have side C, which is great. So out of the 6 pieces of this triangle that we needed, we have 5 of them. So we need to solve for that last side. So in order to get that last side, I'm going to set it up now with angle A and side length A. So let's take a look. I'm going to say the sine of A, put that on the bottom with little a on top, and then over to the side, I will take little b over the sine of B, because I know those are my partners. So I can say 27.4 divided by the sine of 28.7, and I still don't know what little a is, but I know that angle A is what? 49 degrees. So this is good. This is the same thing you just got done doing previous. I want to solve for this side length here, so I have to do the opposite. Instead of dividing by the sine of 49, I'm going to multiply by the sine of 49, and I'm going to do it to the other side also. That will cancel that out. So what I am left with is A equals, now we're going to type this into our calculator, 27.4 times the sine of 49 degrees divided by the sine of 28.7. You can put all of that in your calculator right away, and I think I get 43.06. So I've solved it. I have all my missing sides, so I can come over to my triangle and I can write in 43.06. So I have every single missing piece. So this works out great. I had to use the law of sines because it is an oblique triangle. Alright, let me highlight a couple things right now before we go any further. We were given an angle, and a side. So we're going to write that down as angle, angle, side. If you have a situation where it is angle, angle, side, it's very easy in order to use the law of sines in order to get your answer. Alright, that first one was easy. So anytime I have angle, angle, side, or 2 angles and a side, life is pretty easy. But what you're going to notice in number 2 is I have a side, and an angle, which if you write that the other way, it doesn't work out very well. Anytime I have a side, and an angle, and make sure you write it in that order, we call that the ambiguous case. Ambiguous means there could be 1 answer, 2 answers, or 0 answers. And I'm going to take you through each one of those cases right now. Alright? So if we take a look at this triangle right here, you'll notice that we do have partners, and this is very important. I have side length A, and I have angle A. So because I have those partners, I can use the law of sines. Now, I will go back. We can't use SOHCAHTOA because, or Pythagoras, because we do not have a 90-degree angle. So if you look here, I'm going to have to solve for angle B first. All right? So the first thing that changes is when I write my law of sines, I put my angle on top and my side length on the bottom. Okay, very important. On the previous problem, we did it just the opposite, but that's because we were looking for a side length. And I use my known quantity. I know that it's going to be the sine of 42 divided by 22. So, as I start solving this problem, the first thing I'm going to do is instead of dividing by 12 on the left, I'm going to go ahead and multiply by 12. So I multiply that side by 12 and this side. So those are going to cancel out. And again, when I get to the other side, I can plug that into my calculator. I will get the sine of B equal to sine of 42 times 12 divided by 22, I believe, gives me something that looks like this, 0.36498-ish. All right, and when I have that, now this is a problem that we've been doing since the first unit. I'm trying to solve for an angle. Because I'm trying to solve for an angle, I have to use an inverse trig function. So I'm going to take the inverse sine on both sides. So on this side, I'm going to take the inverse sine, and on the other side, I will take the inverse sine. Those will cancel out, and I will end up with just B on this side. And when I take the inverse of 0.36498, I believe I get 21.4 degrees. Now, here is where the ambiguous case comes in. Not only do I get 21.4 degrees, I also get another answer. All right, you guys just finished your Unit 2 test, and you know that there's two answers. So, when we do the sine, the first answer is 21.4 in our first quadrant. All right, and the second answer is straight across, or 180 minus 21.4. So 180 minus 21.4 is 158.6. Actually, you know what? I don't even have to do that. Look, I can erase, make this look sweet. 58.6 degrees. All right. So here's the deal. I used the law of sines to find my first angle, which was angle B. When I found angle B, I found two answers to it. So here's where we use the ambiguous case. All right, so here's the situation I'm running into right now. The first angle I found was 21.4, so I will plug that in. So 21.4 looks great. All right, I can plug that into my problem, and I can solve for all the rest of the pieces. We'll do that here in a second. The second answer I got was, I think it was 158.6. Now this presents a problem right away. So if you take a look at this, 158 plus 42 is already greater than 180 degrees. Therefore, there's only going to be one solution to this problem. I cannot do anything with that second solution. You might think that this kind of makes sense or doesn't make sense, but as we look, as we keep going, you'll see that this will work out all right. So if I look at my original triangle using the 21.4, the first thing I can do is find angle C. So I can take 180 minus my 42 minus my 21.4, and because triangles have to sum to 180 degrees, I end up with 116.6 degrees. So I know that that missing piece is 116.6. So the last missing piece I need to find is little c, and I don't have a 90-degree angle, but luckily I have some partners, so I'm going to be able to use my law of sines. Because I have an angle and an opposite side, I'm good to go. So I'm looking for angle C, side C. So I put that on top. Sine of 116.6 equals 22 divided by the sine of 42. And we solve this the same way we've been solving everything else. So in order to get C all by itself, I have to multiply by the sine of 116.6, which is going to cancel out. On the other side, I multiply by the sine of 116.6. And when I plug that into my calculator, which I'm sure you're doing right now, I get C equals... Are you guys taking the time to plug it in, or are you just using my work? Put it in your calculator. 29.39. And yes, you should check that work. Number one, make sure I did it right, but also make sure that you're putting it in correctly. Make sure you're closing your parentheses after your angles, and you're getting your 29.39. So again, just to reiterate exactly what we did. We started off with a triangle that was a side-side angle. Because it was side-side angle, it's ambiguous. It could be 1, 2, or 0 solutions. In this case, it was only one solution, because when I plugged in the 158.6 angle in the other triangle, it didn't work out. It was already past 180 degrees. We should probably look at the other two possibilities, huh? Alright, stick around, kids. Here we go. Alright, so flip your note sheet over to the back. I've already drawn out problem number 3, and the first thing I notice is that I have a side-side angle. So again, that tells me there's 2, there's 1, or there's 0 solutions. The problem previous to this, there was 1 solution, so let's see what happens with this one. We do not have a 90-degree angle, so we can't use SOHCAHTOA, but I do have partners. So now I'm able to attack this. The first thing I do is I can find angle B because I have a side length B. So as I write this down, sine of B over 25 equals, and I use the partners on the other side, sine of 85 over 15. Now, we've done this a whole bunch of times, so you guys should start solving this with your algebra. In order to get angle B, I have to multiply both sides by 25. Those are going to cancel out, which means that I will be left on this side with the sine of B. On the other side, again, put this into your calculator. Don't just copy my work as you do it. But when you put in the sine of 85 times 25 divided by... So, as you type this into your calculator, you should get something along 1.660. And again, just like everything else, we have to take the inverse sine of both sides. And sine inverse, those cancel out. And let's see, you put this into your calculator. When I take the inverse sine of 1.66, I get, that's right, no solution. That is outside of the range for a sine. The sine only goes from +1 to -1. So this is an example of when I have a side-side angle and I have 0 solutions. So this is the great part about trig. Sometimes it works, and sometimes it does not. Ouch. Tell me what happened. What happened to your hand?
Daddy, I accidentally scraped it onto the bench.
Did you fall off your bike?
No.
Okay, good. Go get a Band-Aid. Sorry about that. You guys just listened to Abigail explain why she needs a Band-Aid. But we're good. Don't worry, Mrs. Skyman is watching the kids. So, here's our last situation. I think this is the last one we're going to do. If you guys notice, I have side, side, and an angle again. That's an ambiguous case. There could be 0 solutions, 1 or 2. We've already knocked out the 0 and the 1 solution, so I bet this time we're going to look at 2. So, We jump into this problem the same way we've jumped into every single problem. The great part is I don't have a 90-degree angle, but I can use the law of sines. So I have partners again. It looks like I'm going to try and solve for the sine of B, or angle B. And I have the partners between my A's, so I can take the sine of 20.5 divided by 12. Looks like I'm going to take both sides and multiply by 31. Multiplied on that side I also multiply by 31. So those cancel out. That's going to leave me with the sine of B is equal to 0.90. Oh, and again, put this in your calculator. Is your calculator in degrees? So some of you may be frustrated because you're not getting the same answers as I'm getting, and that's one of the problems that people run into. So make sure that's happening. So I have to take the inverse sine of both sides in order to find out what angle B is going to be. So if you type that into your calculator, I end up with, so the inverse sine of 0.90 gives me 65 degrees. Alright? Now, you guys just got done taking a test over this, so not only did you get one answer of 65 degrees, you also got, let's take a look. 65 degrees is your first answer. If we go across, I could also get 180 minus 65, which is 115. So, it's an ambiguous case. I have to look at both of these. Do they work or do they not work? Alright, now we're ready to check and see if these work. So again, I drew two triangles, the exact same triangles. These are the angles and the side lengths given in the problem. The first answer I got was 65 degrees. And the second answer that I got was 115. Now, what you'll notice about this is that both 115 and 65, if I use my triangle sum property, will work. Minus 65, minus 20.5, and I can get an answer for that. And if I come over here, I have 180 minus 65, minus 20.5. Are you taking time to plug this into your calculator? Yes. So, as I subtract, I end up with 94.5, which works in my triangle. Alright, and when I go to the other side, I already see that I made a mistake. I'm sure you guys are yelling at me right now. But I get to use an eraser. So I can subtract 115 and end up with 44.5 degrees. So, now, with both of these triangles, I can find the missing side. Again, I have no 90-degree angle, so I'll have to use my law of sines. So, if I look at my triangle on the left, I can find side C by taking the sine of 94.5 equals, and again, I'm going to use my side A because that was given to me in the problem. Now, you guys should be really, really good at this right now. I multiply both sides by the sine of 94.5. And those are going to cancel out. Multiply by the sine of 94.5. And I end up with an answer of C equals. So, this gives you an answer of 34.15. And, oh yeah, because we have an ambiguous triangle, we have to get the other side. So, you're going to follow the same pattern. When I say it has two answers, I mean it has two full triangle answers. So, we find the other missing side over here. And actually, we can cut right to the chase. We know we need to multiply by the sine of 44.5 on both sides. So when we plug that into our calculator, divided by the sine of 20.5, I think we get an answer of 24. So when I say it's an ambiguous case and it could have two solutions, I mean two full triangle solutions. Alright, I don't think I'm going to help you with the story problem at the bottom. You know you have a sunshine, and you have a pole that tilts towards the sun 8 degrees from the vertical. So if I draw a pole that's 8 degrees from the vertical, that means this is going to be 98 degrees. And it casts a 22-foot shadow. That's pretty easy to figure out. So I know that that's 22 feet. And if I draw my triangle, it tells me that from the tip of the shadow to the top of the pole is 43 degrees. And it asks you to find the height of the pole. So, if you have partners, you can use the law of sines. So take a look at this problem and see what you got. Alright, good luck.